Hi there, this is Jason McManaman, and this is the screen recording for the midterm demo of the CS419 senior project. My team members for Group 6 are Renee McLean and Eric Miller. So to get started, the database that we'll be working with is essentially a bakery that is made up of cakes, ingredients, and recipes. So the first thing I'd like to cover is how to actually get started and set up in our environment. A really helpful web page is this postgreSQL for development with Vagrant. And this walks through pretty much all the steps you need to get started, with a few important things left out that I'll go through. The first piece of software is the virtual machine, and what we used was VirtualBox. This is what the download page looks like. So first you download VirtualBox 5.0, and the other piece of software is basically a wrapper for VirtualBox called Vagrant. So you download Vagrant and make sure everything installs correctly, and then come back here. And the next thing you want to do is make a new folder and clone this Git repository. What this repository has is a Vagrant file that already has all the commands ready to spin up a virtual machine running Ubuntu with PostgreSQL, the latest version already installed, with the host, port, and username and password already set up for you, with instructions on how to access the database, or how to access the virtual machine, I should say. So I also have the instructions basically on how to get set up over here on the left. So once you install VirtualBox and Vagrant and clone the Git repository, you can navigate to the file that has your Vagrant file, which is over here in my terminal. We can see that I'm in the folder that has my Vagrant file, and the command to execute what's in the Vagrant file is called Vagrant up, and that will get the Vagrant up. The first time you run this, it will install everything, but right now it's just telling me that the VirtualBox is running. And since it's running, we can actually SSH into our virtual machine, which we'll do now. Alright, so now we're logged in as Vagrant at PostgreSQL. So now we're in a Linux environment, and the first thing we want to do is install the Python psycopg2 package. What this will be used for later is for actually making our connection to the database so that we can make actual queries and commands to send to it. It's already installed here, and then you start a file that you'll want for the executable. And in my case, I already have the file, a couple versions. We'll be using bakery.py, so we can actually open bakery.py, and we can see that the program is here. I'll be able to go through it a little later in conjunction while running the program over here in Sublime. But for now, the next step is one of the problems that we ran into was right here. When you change to the Postgres user and access the Postgres environment using pSQL, when you try to make a connection from the actual Python file, the password it's looking for is dbpass. However, when you're running Vagrant, you have to actually manually set the password again, even though the Vagrant file does it for you. This is one of the major problems we ran up against, but it is working correctly now. So we can go ahead and change to be the super user Postgres and go into pSQL. All right. So here, the first thing you would do is the statement create database. There's actually already a database created called myapp. So what we can do is connect to myapp, and it lets us know that we're connected to the database myapp. Over here, these are the statements that we actually used to create our database. Once in the pSQL interface, you can create your schema called bakery, and then we have three tables. There's an ingredients table, which is an ingredient ID, which is the primary key, and a name. There's a cake table, which is its primary key, the cake ID, as well as a cake name. And there's the recipe table, which is actually a table of foreign keys to the cake ID and a foreign key to the ingredient ID. And here are just a few insert statements where we insert some cakes, we give them an ID and a name. We insert some ingredients and some recipes. Over here, we can see just an example that we have data in our database by doing a select star from bakery dot cake, and it shows us that we have 4 cakes, which is exactly what we would expect to have. So we can quit pSQL here and find the right command to get back into Vagrant. So now what I'd like to do is actually run the program and talk about what we have so far for an interface. So if we go to the actual code, I'll walk through a bit of it here. We have a VM running and we have a database running and listening on a particular port. One of the major problems we ran into was that we were trying to run the Python program on a local machine trying to access the database running in the VM, which was absolutely possible. The problem was when we tried to get together and use different systems. Some of us were on Linux, some on Mac, Windows, and we really ran into an issue until we decided just to run everything within the VM. When we decided to do that, when the VM is set up, it automatically forwards the port, it forwards the port to 15432. So on the local machine, that connection was working great. The problem that we found was that in the VM, it's forwarding from port 5432. So when we changed situations to try and run everything, including the Python program, inside the VM, we had to change the port number. And once we did, we had a successful connection again. So here we see we import the ncurses library as well as the psychopg2 library. The connection we make by connecting to the database with the username, password, localhost, and the port number. The ncurses library is essentially each function is bringing up a new window, and you can give the window XY coordinates and what you want displayed there. And the way you do it is in main, you start with a standard screen and you initialize it. And then you can make these color pairs where later on in the program you can reference back to them and say, I want this to be this particular color pair that you saved up here. So for the home screen, we have essentially making it the max size possible, and then adding a border and a name at these particular XY coordinates of this particular color, and adding a string to the window at these coordinates with this text. And what this loop does is we set end to 1, and while it's not 0, so we know it's 1, if the cursor is the original value, you can set this text to this color. And what that does is it makes it look highlighted. So let me go ahead and run this in parallel so we can look at the code and the program at the same time. So here's our home screen. This is what we're looking at in this menu. Ingredients, the cursor is 1, so the color pair is set to make it look highlighted. If the cursor is not 1, it'll be set to color pair 3, which is what these are. So if we cursor down, now the cursor is 2, and cakes is color pair 1. And that's the basic way that the way the interface works. And here's code to decide how the user input keying down or up changes which way the cursor goes. And then this lets the program know what the user has chosen. So for an example, let's say we choose ingredients. The program will execute ingredient menu, which is this function, which is just another window laid on top of the original window. And basically, the same layout is used, just with different options, but the same color pairs and the same idea behind moving the cursor around and changing the color pairs available. So you can see in the program, if we go to ingredients, we can list ingredients. My apologies, list ingredients. And it brings up a new window, which is drawn on top of the home ingredients window as a list of the ingredients in the database. Right now, this is currently dummy data, just to make sure we have the interface working. But we can go down here. We can go to the next page and see more ingredients. We can go back, and we can go back to the ingredient menu. If we add an ingredient, we can enter the name, hit enter, and it'll let us know that we entered the ingredient. If we head back to the main menu, we can also look at cakes. We can search by ingredient, or if I search for basil, it will find it in the cake menu and you'll be able to select it. You can add a cake. That's probably not a very good cake, but it'll have one ingredient. It'll just be basil. And we'll have one of those each, and it'll let you know that you've entered a new cake. Again, this is all dummy data. The one option that is currently implemented with an actual connection to the database and returning of data is the list cakes. When we hit list cakes, it'll execute the function cake list, which is down here a ways, definition of cake list. And what will happen is that a new cursor will be made, and this SQL command will be executed. When this executes, we can use the fetch all method of cursor to take what it returns and put it into this object list. As you can see, the object list is accessed by its index based on how many items are returned. For this example, there are 4 cakes that will be returned, so we only really manually want to look up through index plus 3. And so I'll go ahead and choose list cakes, and we'll see our cakes that we saw earlier are correctly returned to the screen in this new window that was drawn on top of the cake menu. Unfortunately, right now there is an issue with the cursor that we haven't quite worked out. So when you list the cakes, it does unfortunately freeze. But it is definitely a start, and we have a successful connection to the database. The interface is functional, and we have basically all the menus that we were planning on having based on our diagrams and paper prototypes that we shared in our earlier updates. Right now, our next steps are really to make the rest of the connections for listing cakes and listing ingredients and fix some of these formatting errors that are leftovers from the returned tuple from this fetch all statement. But that is where we are. I hope that we're on the right track and that it looks good. And if you have any questions, please let us know. Again, this is for Group 6 with Renee, Eric, and me, Jason. Thank you.